All right, guys, welcome to a new unit 2B or not to be. That's an English joke in a math class. Unit 2B, and we're going to start graphing. And this is very important stuff, guys, because this carries forward to other years, to next year, to later on in the course, and that sort of thing. So we're going to graph a bunch of functions, and the basic functions. The first one is y equals x squared. The next one is just your plain old line y equals x. Let me just change this to, looks a little better if we put it on, where's this thing? Settings, where's the settings? Tours, oh man, you get scared of it. Oh, here we go, this thing here. Graph setting, projector mode, so we can see a little better. And next up, we have y equals the root of x. Now, how do I put that on this thing here? Down here is a root button. X, looks like that. And finally, we have 1, everyone's favorite, 1 over x. So let's take a look at each of these, and we need to know all of them separately first before we move on. So first of all, let's go and look at our blue friend here, x. Y equals x, straight line, over 1, up 1, has a slope of 1, and that's it. Okay, so we're going to move these around, and when we move them around, we need to know where they started from. So you can't really say, I moved this if you didn't know where it was in the first place. Okay, so that's what y equals x looks like. Your basic parabola, the key to this basic parabola is, and our scale's a little messed up here, so let me get a little closer. So our scale's the same. You go over 1, up 1, and then over 1, up 3, over 4, and then draw the mirrored points. So y equals x squared as your basic step pattern. That's that one. And then we have 1 over, root x, which is essentially a sideways parabola. So if you could turn your head sideways right now to the right, you'll notice that this is essentially the left arm of a parabola that's going sideways. And I have this here, and if I look at how to graph this, I go, so if I'm turning sideways, I go over 1, up 1, over 1, up 1, 2, 3. I put a point here, okay, at right here at 4, 2, okay? And then that's it. And then the next one would be over 1, or over 1, up 5. Now over being in the positive y direction. Okay, so that's root x. And the last one, everyone's favorite, 1 over x. And the way to sketch this, so if I look at this, this is what it looks like, and I'll show you how to sketch it in a second. So it looks something like this. And these ends go on forever. They never touch here, they never touch here. And I'll talk about how to sketch this in a second. But the key points here are that this is centered at 0, 0, or the origin. And then if I zoom in, you'll notice that this point here, it's here. That point here is 1, 1. This point here is -1, -1. So those are the key points. So when we move them from there. So the first part of this, so this would be Unit 2B, Day 1. And what we're doing here is we're moving them. And the way we move them is by adding or subtracting a horizontal or a vertical shift. So I have my function, whatever it is. So let's say I have x squared. And if I add something outside of, oops, not B. If I add something outside of the function, so if I have f at x and I add outside of the function, what I'm adding is a vertical transformation or translation, either up or down. So if I add something outside of the x, and you'll see what I'm talking about in a bit when I write them out, it moves up or down. And this, if it's positive, it moves up. If it's negative, it goes down. So if I have, for example, x squared plus 3, instead of starting here and going over 1, up 1, over 1, up 3, which is my basic parabola, and connect the dots, and that doesn't look good, but you know what I'm talking about. What I'm just going to do is take this and move it up 3. And the way to move it up 3 is to move each spot up 3. And the best way to do it is just to move the vertex. So I take this guy and I move it up 1, 2, 3 here. My next spot is over 1, up 1, over 1, up 3. So that I haven't stretched it. That's tomorrow's lesson. And I connect the dots like this, and there's my parabola. So this is x squared plus 3. X squared minus 3, we'll just take this guy and move it down here. And then you would sketch it and do it properly and move from there. Domain and range. Whenever you do domain and range, you just look at your new graph. So here's my domain and range from this graph. What's my domain? My domain is x is a real number. I'm not limited in my x this way. I'm not limited in my x this way, so there's no restrictions. My range would be y is a real number. And in this case, y has to be greater than or equal to 3. So remember how to do domain and range. Domain and range. Okay, and put your funny brackets on them. So that's for your parabola. When you get to something like, sorry, before we move on from the parabola, if I have an addition or a subtraction inside the bracket here, so I always ask, is it on the x or is it on the function? If it's on the function, it's outside, it's on x squared. But if it's on the x, directly on the x, it's horizontal. If it's on the function, it's vertical. If it's on the horizontal, it is if it's on the x, sorry, it's horizontal. So this is right on the x. The -5, that I'm taking 5 and I'm subtracting it from the x directly, not outside the bracket. So if I have that, you would have told me if before this class started, if I said, tell me about this parabola, you would have told me, okay, this parabola here has a vertex of 5, because you would have changed the sign, 0. And what does that mean as far as transformation goes? 5, 0 means it would start 1, 2, 3, 4, 5 over here, and then it would just follow the same pattern and look like something like this. Okay, so what's happened as far as translation goes? It's moved to the right 5 units. And what you're looking for a horizontal translation is this is of the form y is equal to fx minus d, f at x minus d. The negative is built into the equation. Okay, so when you take this 5 out, just like we do with parabolas, and I ask, hey, which way did it move, or give me the value of d, d is not -5. The negative is built into it. You would tell me that d is 5. Just like if I said, if I had this, and we're talking about zeros, and these are my zeros. Okay, zeros are again horizontal. You would take the negative out. Okay, and same with this. You take the negative out, you change it, and you say that d is equal to 5. D equal to 5 means move right 5. So you take your parabola and move it right to 5. Okay, so that's your parabolas. If I had other shapes, I would just move them also. So when I have something like this, so if I have this, for example, our old friend 1 over x, and everyone hates that. So 1 over x looks like this. Put your main point here, your main point here. Here is where my asymptotes are, so they're hard to see. Asymptotes mean they don't hit this line. They don't hit this line. The graph doesn't hit this line. And then when you make when you sketch your graph, go through the 0 and level off. Curve, that's a bit too flat, and curve it like this. Okay, so that's 1 over x. F at x is equal to 1 over x. If I'm going to play around with that, if I add right to the x, so if I put a 3 here, that's right on the x. If it's on the x, it's horizontal. If it's horizontal, I got to change the sign. So this would say move left 3. And if I was to move this left 3, the way to do that is start with this meeting of the asymptotes at 0, 0, and move that left 3. So 1, 2, 3. Draw your asymptotes here, like this. Okay, this one is here. The other one stays where it was. Okay, so I'm still like this. And then my point here is just 1 over. Okay, it's still over 1, up 1 from here, over 1, up 1 from here. And then connect the dots like this. And there is 1 over x plus 3. If I had the 3 on the outside, so if I had 1 over x all plus 3, I would take this and move it up. So if I do this in yellow, my asymptotes would now meet at 1, 2, 3. They would meet here somewhere. So I'd have this asymptote here, this asymptote here. My key point is here, my other key point is here, and I'd move like this. All right. If I had a bunch of stuff together, so let's do this the way we did it in the notes. So let me clean this whole thing up here. Okay, so let's clean up the edges here also. All right, so we're all cleaned up here. If I had something that combined them, so I'm going to go in red here. If I had g at x is equal to 1x, we'll change the sign here, plus 1, no, plus 4, let's get out of the way, plus 4 plus 2, you ask yourself, okay, first of all, one thing that gets a little confusing is we can write this in function notation. What this is saying is if I had my normal f at x, the 4 is adding right onto the x, and the 2 is adding to the function. So this is g of x in function notation is take my base function, if f at x is equal to 1 over x, what I do instead of writing 1 over x here, I replace it with f at x. I add 4 right to the x, so right here, it's here, and that goes there, and then I add to the whole function. So this is function notation of this here. So what this is saying is that's fine. But what I want to know is what happens. That's the key here. This says moving left 4 and up 2. So if I go left 4, 1, 2, 3, 4, and up 2, my guys are going to meet, my asymptotes are going to meet right here. So this one comes down this way. This one goes this way. Okay, what's my key point? My key point is 1 over 1 up 1, like this. Connect the dots, over 1 here, connect the dots, and you're done. Okay, so that's what that guy looks like there. Left 4, up 2. Okay, so that's your 1 over x. We played around. Lines are a pain. I'll save lines for last. And let's clear this up and do a root x one real quick before we're out of time. I'll say, you know what, I'll save lines for later. But if I have root x, so root x is my function. If f at x is my function of root x, and I come back and I say g of x is equal to the root of x, I don't know, minus 6. No, let's go plus 6. Just otherwise it won't fit. Plus 6 minus 1. So my original function is this guy right here. F at x is, so over 1 like this. I'm turning my head as I do this, over 1 up 3. And this is my normal root of x. And I say, what's this look like? Well, this is take f at x. And what you're going to do is oh, sorry, that's not right. I should have put that there. What's this look like in function notation? I'm going to add 6 to the x and subtract 1 from the entire function. So that's g at x in function notation. And what that means is go left 6, down 1. So I just take this, I'll do it in red. I take this vertex and go left 6, so 2, 4, 6, and down 1 here. And then I just draw my points accordingly. Okay, so I think it's pretty straightforward stuff. The thing about a line, where a line gets to be a problem, is if I have this, f at x, if f at x is equal to x, and then I come back and say, this right here, hey, is this, I have an equation of a line, and it's this, y equals x plus 3, okay? Am I adding 3 to the function, or am I adding 3 to x? And the answer is you're both right, okay? So is this, well, let's draw my basic line first. If I drew this line right here, okay, it goes like that, that's y equals x. Is this on the function, right, because x is the function? If it was on the function, that would say I'm moving up 3. So am I moving up 3? 1, 2, 3. Is this the line I mean? Well, maybe. If I came back and I said, hold on, I'm not moving up 3. This is adding 3 to the function. I'm moving left 3. Well, take a look. If I drew this and took this over 1, 2, 3, and I'd drawn this problem in the first place, I would have the exact same line. So the confusing part about line is up goes with left, and right goes with, down goes with right. So there's an infinite number of lines. Did I move that way or did I move that way? And it could be both. So lines get a bit annoying actually when it comes to this. Okay, anytime you do domain and range, just get your graph. From your graph, get your domain and range. And I forgot to do domain and range earlier about the 1 over x. So let me just graph. Let me go back a bit. See if I can just use this magic of reverse. Wait, let's go back in time here. Back to the future. Okay, so if I go here and I go just to this one, so let me go back one, forward one. If I go to the one in yellow here, so look at this guy here. I'll do it in blue. So this one here has been moved, and you want to know about domain and range. When I do my domain, x is a real number because it's a line. And then if you say to yourself, tell me about x. Well, x can't be here. I don't, my line does not pass here. So what you say is x is like a restriction. X cannot be equal to 0. And that's how you do domain. Y is a real number, and y cannot be, in this case, y cannot be, I think we had 3. Okay, so domain and range is a little bit different for that. Okay, that's a long video. Hopefully that made sense. Take care. Bye.